Okay, so we have another question here. I just wanted to make a quick video here just to kind of uh, work my way through this one because I figured I could maybe use a little bit more explanation. So let's give it a look. Um, okay, so here what we have is we're told that the game of euchre uses only nines, tens, jacks, queens, kings, and aces from all of or from a standard deck. How many five cards hands have all red? Okay, so first off, I'm just going to identify what's in our set here. So we have four nines. So we have a 9, 9, 9, 9. We have a 10, a 10, a 10, and a 10. We have a jack, a jack, a jack, and a jack. We have a queen, a queen, a queen, and a queen. And then lastly, we have a king, a king, a king, and a king. So, I'm spacing these out a little bit. So I'm just kind of doing this video on the fly here. Okay, so remember half of these are going to be red because half the cards are red, half the cards are black. So I'm just going to make half of them red here. Okay, and this is just to give you a bit of a visual representation of what's going on here. Okay, so if we're picking five cards, they want us to determine how many cards are going to be all, or how many five card hands would be all red. So it's actually pretty simple. In total here, ooh, I forgot a set here. I forgot aces. Okay, so for A here, all red cards, it's just going to simply be we have in total how many red cards do we have in total? We have 2, 4, 6, 8, 10, 12. There's 12 in total, and we're going to choose 5. That's all there is. There's 12 red cards, 12 different red cards. We're going to choose 5 of them, and that's all you have to do for that. So let me just work that out on my calculator here. 792. 792 ways for that to occur. Okay, so for B here, they ask us uh, how we want to have at least 2 red card, or yeah, at least 2 red cards. So what? So I'm going to do so that means we could have either 3 red cards, 4 red cards, or 5 red cards. So the key thing to understand about this here is that we can actually, because this is the word or, we can have 3 red cards, 4 red cards, or 5 red cards. We're actually going to add in each case. So I'm going to go 12, C, 3, and then remember we have to account for the other. There's 12 black cards. We got to account for the fact that we're gonna have to pick 2 black cards, and there's 12 black cards because we have to pick 5 cards in total, right? So that's one. So that's either 3 red cards, or that's a 3 red card set. Then we got to do the 4 red card set. So that would be 12C4 times 12C1, and then lastly we have 5 red cards. Okay, so that would simply be 12C0 times 12C0. Sorry. 12C5 times 12C0. And that's all there is to that. I can quickly figure this out here. Actually, I didn't pre-work this out here, but here. I'll do that right now. So that's going to be 220 times 66 plus 495 times 12, and then lastly plus 792 times 1. So I'll just write that out quickly. times 66 plus 495 times 12 plus 792 times 1. Okay, so let me just throw that into my calculator here that I have built in. I use Microsoft Mathematics for a lot of these calculations. It's great if you're not using it. 21,252. Okay, and that's how we do that. Okay, so lastly here we have, for this last one here, we have at most 2 red cards. So that means we could have either 0 red cards, 1 red card, or 2 red cards. That's at most 2 red cards. None, 1, or 2. So if we have none, that's going to be 12 choose 0 times 12 choose 1. Sorry, no, times 12 choose 5. Because if we remember, if we have no red cards, that means we're going to have 0 red cards and we're going to have 5 black cards. 12 choose 5. Okay, or, so we're adding, we can have 1 red card, so 12 choose 1 times 12 choose 4, because we're going to have 1 red card of 12, and then we're going to have 4 black cards of 12. And then lastly, if we have 2 red cards, that means we're going to have 12 choose 2 times 12 choose 3. Okay, so this last one here is pretty simple enough to do. That's going to be 220 times 66. We did that one before. Actually, I think I did. Yeah, I did all these calculations. This number is actually going to be, it might actually be the same as the previous one. 12 choose 0 is 1. 12 choose 5 is 792. And then 12 choose 1 is 12. And 495. What do you know? This actually ends up being the exact same number, exact same answer. So at least 2 red cards is the same probability as at most 2 red cards. That's kind of interesting. And I guess it kind of makes sense because if you think about it, at least 2 red cards would have to be the same answer as at least 2 black cards, and at most 2 red cards is the same thing as at least 2 black cards. So that's how that worked out that way. Kind of an interesting question. So hopefully that made some sense, and I didn't make this video for nothing. All right.